Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will use quadratic equations to solve worded problems. So the process is the same. Let x be whatever you're trying to find, then form an equation, and then you solve it using the methods we've gone through in previous classes. So let's look at this example. The length of a rectangle 8 centimeters longer than the width, the area 65 centimeters squared. What are the dimensions of the rectangle? So we're going to start off by letting x equal what we're trying to find. So here we want to find the length and the width. So let's just let x equal the width. So if the width of the rectangle is x and the length is 8 centimeters longer, x plus 8 will be the length. We don't want to introduce a second variable. We don't want to say let x equal the width and let y equal the length. We've never looked at solving quadratics that have x's and y's, just that have x's. So what we're saying, we have a rectangle like this. The width is x, the length is 8 centimeters longer, and its area is 65 centimeters squared. So we want to find what x is, what the width is, and then we'll know the length. So second step of forming our equation, we have width times length. That is the area of any rectangle. Width times length equals 65. So then the final step is we just solve this. So we're going to expand the brackets. And now we're going to solve this like we have done any other. So we need first to make one side equal 0. We're going to subtract this 65 from both sides. So we get x squared plus 8x minus 65 equals 0. So you can solve this equation here by factorizing or using the quadratic formula. So I'll factorize this. So we need to find two numbers that multiply to negative 65 and add to 8. So 65 doesn't have too many factors. Those factors turn out to be 13 and minus 5. So 13 times negative 5 gives you negative 65. 13 plus negative 5 gives you positive 8. So if the first bracket equals 0, we get x equals negative 13. Or if the second bracket equals 0, we get x equals 5. Now, because in this one we're talking about x being the width of the rectangle, we can't have a negative answer. So we don't accept this one. So our only possible answer is the width is 5, x equals 5. So if the width equals 5 centimeters, then the length equals 13 centimeters. And then we're done. Let's look at another example. So let's look at this one here. The product of two consecutive numbers is 132. What are the two numbers? So we're going to start off by letting x equal one of them. So I'm just going to let x be the smaller number. So consecutive means one after the other. So if x is the smaller number, x plus 1 will be the larger number. Again, we don't want to let one be x and one be y. We don't know how to solve quadratic equations with x's and y's. So that's the first step done. So the second step, what we're going to do is form an equation. So the product means time. So these two numbers multiplied together gives 132. So third step, we're going to solve. So I'm going to expand the brackets. And now I need one side equal 0. I'm going to subtract 132 from both sides. So I can solve this quadratic equation here either by factorization or quadratic formula. So it might be a bit hard to use factorization because we have a big number here. So let's use the quadratic formula. So I've written the quadratic formula up here for you. Remember, a is the number in front of x squared. So in this case, a is 1. B is the number in front of x, which is also 1. And c is the constant term. So we first calculate the discriminant. So it's b squared minus 4 times a times c. And that gives us 529. So there will be two solutions. So solutions, we have x equals minus b plus or minus the square root of the discriminant over 2 times a. So we get minus 1 plus root 529 over 2. So that actually gives us 11, or minus 1 minus root 529 over 2 gives us negative 12. So the smaller number is either 11 or negative 12. So the two numbers, if the smaller number is 11, the larger is 12. If the smaller number is negative 12, the larger is negative 11. So either of these works, 11 and 12 or minus 12 and minus 11. So now we're going to look at a very similar question to this. So this time we're told the product of two consecutive even numbers is 224, and we'll find the two numbers. So we're going to solve this very similar to the last one. Now, if we let x be the smaller number, the larger number is going to be x plus 2. If you're at an even number, you have to add 2 to get to the next even number. So everything else about the way we solve it's going to be the same. So we're going to have smaller number times larger number is equal to 224. So we're going to expand the brackets and then subtract 224 from both sides. So I'm going to solve this using the quadratic formula. 224 is a big number with a lot of factors. That's why the quadratic formula will be easier. So here, A is 1. B is 2, C is negative 224. So to use the quadratic formula, I first calculate the discriminant. So it's going to be b squared minus 4 times A times C. And that gives us 900. So x will be minus b plus or minus the square root of the discriminant over 2 times a. So minus 2 plus square root of 900 divided by 2, that gives us 14. And minus 2 minus root 900 over 2 gives minus 16. So once again, the smaller number could be 14 or minus 16. If the smaller number is 14, the two numbers are 14 and 16. If the smaller number is negative 16, the two numbers are minus 16 and minus 14. Okay, so we're done. Let's look at a different type of question now. So we are now going to use quadratic equations to find x in each of these triangles. So because they're right-angled, we can use Pythagoras. Now the first part is already defined for us. We're already told what x is in each case. So we can go straight to forming an equation. So in this triangle here, we have shorter side squared plus shorter side squared equals longer side squared. We need that in brackets. So we just need to solve this equation. So what I'm going to do is first expand these brackets over here. So expanding those brackets, using FOIL, you should get x squared plus 6x plus 9. Just using FOIL. So I've got x squared plus 9 squared is 81 equals x squared plus 6x plus 9. So to solve this equation, I need to make one side equal 0. So I can subtract x squared from both sides and it will actually cancel each other out. This one actually reduces to a linear equation. I have 6x plus 9 equals 81. Subtract 9 from both sides and then divide each side by 6. So I get here x equals 12. So this is, using Pythagoras, 9, 12, 15. 9 squared plus 12 squared equals 15, and we're done. So this one on the right-hand side is a little harder because x is in all three sides. So using Pythagoras, we have shorter side squared plus shorter side squared equals longer side squared. So we now expand all of these brackets using FOIL. So if I expand x plus 2 all squared, I get this. If I expand x plus 9 squared, I get this. And x plus 11 squared, I get this. So let's make this left-hand side easier to deal with by collecting like terms. So x squared plus x squared, 4x plus 18x, and then 4 plus 81. And then that is still equal to x squared plus 22x plus 121. So to solve this, I need to get one side equal to 0. So I'm going to subtract x squared from both sides. So this is what happened. X squared disappears from this side. 2x squared minus x squared gives me that. Now I'm going to subtract 22x from both sides. So they're actually going to cancel out here, which is nice. Now I'm going to subtract 121 from both sides. So 85 minus 121 gives me minus 36. So I have now one side equal to 0, so I can solve this using factorization or quadratic formula. So it's probably easiest to use factorization here. This is just the difference of two squares. So x plus 6 times x minus 6 is equal to 0. So we have two possible solutions here. If x minus 6 equals 0, x equals 6. If x plus 6 equals 0, we get x equals minus 6. But because x is the length of a triangle, it can't be negative. So we reject that solution, and our final answer is 6. So this will be 8, 15, 17. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.